2, 1. Okay, let's go. So when you're studying these sequences in grade 11, you may run into this Fibonacci sequence, which depending on how it is written, kind of the starting point might change on you a little bit, but the pattern is going to be the same. It is a pretty famous sequence, so I think it's worth at least hearing about it. So I'm not going to go into huge amounts of details, but I will present it to you and I'll show you how you can come up with a very simple recursive way of summarizing the Fibonacci sequence. Now, there are actually ways to do a general summarization for the nth term in the sequence for Fibonacci. You can certainly find it on the web, you know, when you're searching it up, but that's not the point of this particular video. It is more to introduce you to it. So with the Fibonacci sequence, so you'll notice that it's going to be presented to you either in this way, or it will be omitted, the 0, that is. So it may be presented to you in this way. Or I think the original Fibonacci sequence was kind of presented in this way. So, you might see one of these presentations for you. So, I mean, the only thing really that will change is your first term or the first 2 terms, but the rest is pretty much the same, okay? So I'm going to take the first term and then we'll go from there, and then you'll notice how to come up with the pattern. So the pattern originally came kind of studying rabbits or bunnies, and then pairs of bunnies as they kind of populate, on and on in terms of generations. Okay, and so what you will have is the sequences are generated, or the next term in the sequence is generated by taking the first 2, okay, or the past 2 numbers, and then adding them together to come up with the third one. Okay, so you can take that, and then that pattern continues. So if I wanted to actually define this Fibonacci sequence, so what I would say is that the term, so term n, in the sequence is equal to basically the previous term, so term n minus 1, added to the n minus 2 term. Now this of course will only work for n, I guess, greater than 2, okay, for here. And n is the element of natural numbers, okay, just like for any sequence. So for instance, if you're going to be starting this off, so term 1 is going to be defined as 0, and then for example term 2 is going to be defined as 1, and then you can plug this in. This would be your recursive way of defining this Fibonacci sequence. If you're going to be finding that maybe your teachers presenting to you in this way, where they don't start with a 0 but they start with the 1, the sequence will be the same. The only difference is now T1, so term 1 would have been equal to 1, and term 2 would have been equal to 1 as well. All right, and then if you're being presented in this way, then again, so term 1 would have been equal to 1 and term 2 would have been equal to 2, but the actual recursive pattern, so this pattern, is going to be the same. So when often studying this particular sequence, sometimes you may want to try to see the ratio between consecutive terms. Now, of course, we can't really take the ratio of 1 divided by 0 because it's going to give us undefined. But the rest, it's pretty interesting to note that in these sequence, if you try to take the ratio, just as we did, for instance, in the geometric sequence, right, where we have a consistent ratio, then we had a very nice formula, okay, for the nth term. Now, in this case, if we try to find the ratio, it's not consistently the same. But as you move further and further in the sequences, you do find that, it looks like it's somehow like converging to some particular sequence. And it is true, it's going to try to tend towards a particular number. So as you get higher and higher, you can almost approximate by a geometric sequence as the nth term grows, okay? So I'll show you, as I said, so we can't really, if we try the ratio, so if we try to find the ratio between these, So if you go and start with 1 over 0, well, that's unfortunately undefined. Now you can continue. You can say, okay, the next ratio is 1 over 1, which is going to be equal to 1. And then, as you continue this pattern, okay, so then the next one's going to be 2 over 1. So the ratio is 2. So clearly, the ratio is not the same. But notice what's going to start happening as we keep going through these. And I'm going to do several of these ratios in kind of fast forward way. And then hopefully you'll see that these numbers are going to start tending to something which is, that's interesting. It looks like it is tending towards a ratio. So let me show you that. All right, so welcome back. Okay, so here it is. So here are the ratios. So notice it was 1, 2, 1.5, 1.6666, and so on, 1.6, 1.625, 1.615, and so on, 1.619, 1.617, 1.618. So notice it looks like it is trying to tend towards something around 1.61, okay, and it's heading on. And as you keep going through these ratios, it is actually true. It tends towards that. And maybe your teachers might talk about, and it kind of is called maybe the golden rule, okay, for this. But I wanted to point this out to you, okay, so this Fibonacci sequence. And then this ratio that you have, you can continue this pattern. I'm going to stop in here, but for yourself, you may notice that, well, it doesn't really have a ratio like a geometric series, which isn't really nice. Which provides us a nice formula for any sequence which is geometric. This one isn't exactly geometric, but it looks after a while like it almost is. Okay, so you can approximate the Fibonacci sequence. If somebody asks you in the future, what's the, 200th term? So instead of going and finding the sequence by this recursive pattern, like we have done here, you can kind of cheat a little bit and you can say, well, I kind of know more or less what the ratio is, right? So it's around 1.61 something. So give or take, you can approximate what the 200th term might be by just using the geometric series. Okay, so the formula, if you recall, it is kind of starting off from your term 1, and then eventually, okay, it heads off into, so your actual ratio, and then n minus 1. Now, when you're doing this approximation, don't take the first term, okay? So cheat a little bit for yourself, okay, in terms of the series, because notice that originally, the first few terms, okay, kind of right here, they don't have that 1.61 something, okay? So what I recommend is if you want to cheat, start your Fibonacci sequence kind of, let's say maybe somewhere around, okay, like 8 or 13, call that your first term, and then approximate your ratios from then, so you're going to be shifting your sequence by a few terms, and then you can always shift back to find whatever the 200th term or something like that. So that's just a hint for you if, your teachers pull you in that direction. So that's about it. So this is the Fibonacci sequence, okay, that you have, and hopefully you might run into it in grade 11, maybe for the first time, and later on you can do all kinds of wonderful things with Fibonacci sequence. Thanks for watching. See you in a future video.